Welcome to RJ Data Science. All right, so today we're going to tackle a problem that I know every developer runs into. How do you take that awesome Gradio app you just built and make sure it runs perfectly, anywhere for anyone? Well, the answer is Docker, and we're going to break down exactly how you can do it step by step. We have all been there, right? You build something amazing on your own machine, it's working like a dream, but then the second you try to share it, poof, it just completely breaks. This quote from Tech with Tim just hits the nail on the head. It perfectly captures that universal frustration. And this is where that infamous phrase comes from, but it works on my machine. See, the problem is that your computer is this unique, perfectly tuned environment. It has specific versions of Python, certain libraries, all these little configurations that another computer almost certainly won't have. And that's what makes sharing and deploying your apps such a headache. So what's the solution? What's the magic trick here? It's Docker. Honestly, the best way to think about it is that you're creating a self-contained box for your application. And this isn't just a box for your code. It's a box that holds everything your code needs to run. The right version of Python, all the specific libraries, even the system tools. It's a complete, portable little world for your app. With Docker, what you're doing is packaging your app into something we call a container. This process, containerizing your app, bundles its entire environment together. And what that means is, no matter where you send this container, to a friend, to a cloud server, anywhere, it's going to work exactly the same way every single time. So to get a little more precise, what we're actually building here is called a container image. Just think of it as this lightweight, standalone package that has absolutely everything your software needs to run. The code, the runtime, system tools, all the libraries, the whole shebang. This is how we get rid of those missing dependency errors for good. Okay, so why are we going through all this trouble? Well, there are three massive wins here. First, consistency. It completely solves that works on my machine problem. Done. Second, portability. You can run this container on your laptop, your buddy's computer, or a massive cloud server with zero changes. And finally, scalability. When your app blows up and gets super popular, Docker works perfectly with tools like Kubernetes to handle all that new demand. So, how do we actually do this? You're probably thinking it's going to be super complicated, right? Well, you might be surprised at how simple it is. We only need 3 key files to package up our entire Gradio app. Let's check them out one by one. First up, we've got our application itself, app.py. For this demo, we're keeping it super simple. It's just a basic Gradio interface. You can see it's got a function called greet that takes a name and just returns a hello message. This is the core piece of logic we want to package up. Next up is the requirements.txt file. Now, if you've done any Python development, you've seen this before. It's basically a shopping list for our app. It just lists all the external libraries our application needs to run. In our simple case, it's literally just the Gradio library itself. A real-world app, though, might have pandas, NumPy, PyTorch, all listed right here. And finally, here's the magic ingredient, the Dockerfile. Think of this file as the blueprint, or maybe like an IKEA instruction manual. It's a step-by-step recipe that tells Docker exactly how to build the container for our app. It might look a little like code, but it's really just a set of instructions. Let's just walk through this so it's not so intimidating. First, from tells Docker, hey, go grab a clean, official Python environment for us. Then, workdir creates a folder inside the container just to keep things organized. Copy moves our app.py and requirements.txt right into that folder. The run command then uses pip to install all the libraries from our little shopping list. Expose opens up the port that Gradio uses, and that env line is really important. It makes sure the app is accessible from outside the container. And finally, cmd gives the container its one job. When you start up, run our Python app. So with those 3 files in place, we are ready for the final step. It's time to use our Docker file to build the image and then run it as a live container. This is where it all comes together. This is the payoff. The first command is docker build. We use the -t flag to tag our image with a name that's easy to remember. In this case, we'll call it Gradio app. Now that single dot at the end is super important. It just tells Docker that the Docker file and our app files are right here in the current directory. This command reads our recipe and builds that self-contained image we've been talking about. Once the image is built, we use Docker run to bring it to life. The -p flag stands for port mapping. It basically connects the Gradio port inside the container, which is 7860, to the very same port on our actual computer so we can get to it in a browser. Then we just tell it the name of the image we want to run, Gradio app. And that's it, seriously. If you now open up a web browser and go to localhost on port 7860, you will see your Gradio application running live, perfectly isolated inside its Docker container. We've done it. We've successfully deployed it. Okay, so you've got the fundamentals down, which is awesome. Now let's quickly cover a few next-level tips. These are best practices that will make your Docker images smaller, faster, and more secure, which becomes really, really important for bigger, production-level applications. Here are 4 key things to remember. First, always try to start with a smaller base image like Python Slim to keep your final container nice and lean. Second, for more complex apps, look into multi-stage builds. They let you separate your build tools from the final image, making it smaller and way more secure. Third, a big one, never use the latest tag. Always specify exact versions to make sure your builds are predictable every single time. And finally, here's a really clever trick. Structure your Dockerfile so your dependencies, which rarely change, get installed before you copy your source code, which changes all the time. This takes advantage of Docker's caching and makes your future builds way, way faster. So, you've successfully packaged your application. You've made it consistent, reliable, and portable. It can run absolutely anywhere Docker is installed. So that really just leaves one final question to think about. Where are you going to deploy it next? A cloud server? A tiny Raspberry Pi? The possibilities are now wide open. Hey, thanks for watching this explainer. I really hope you found it useful for your own projects. If you did, please do me a favor and like, share, and subscribe to RJ Data Science for